Welcome everyone, this is Dartisans, episode 5. Today's topic, the Dart virtual machine, with special guests from the Dart virtual machine. We have engineers who work on the project with us today to talk about the project, answer your questions, and give us an idea of what's been going on with the VM, what they're working on now, and perhaps even what they see coming down the pipe for the VM. This is the Dart Hangout, and we encourage everyone to participate. You can join us at html5rocks.com/live to watch this live feed. Also, there's a chat embedded there. Also, links to the moderator. We will be taking your questions later on, so please do vote up and down the questions there and submit your own, of course. And hopefully you can join us. So add a comment to the original post for this broadcast, and we'll try to add you to our circles and invite you to the Hangout. This is for everyone to participate, so we hope you do provide your questions and jump in and join us. Before we introduce the Dart VM team here who's joined us, just a couple news in the Dart community that I found pretty interesting and cool over the past couple weeks I thought I'd share with everyone. This is real big thanks to Dart Watch. They're on Google+, and Chris Bucket, who runs that page, has been doing a great job collecting all of the news. So let me just run through some of the cool things that have been going on. A couple weekends ago, there were 5 different Dart hackathons across the globe. London, Indonesia, Tokyo, Kiev, and Lviv, Ukraine, and saw some really cool demos, feedback, projects come out of these hackathons. We'll be posting a summary of what everyone's been working on and pointing out some of the winning teams soon on news.dartlang.org, so do follow along there. We also, May 24th is an introduction to Dart in Munich, Germany. I think that's a collaboration with a couple different GTUGs and jugs and different user groups and meetups there. Some Dart engineers will be on hand, so that's May 24th in Munich. Please do join them. Alexander Orlov is organizing a Dart hackathon in Munich, much in the style of the global hackathons that have been happening all over. Alexander is an early adopter in the Dart project, and he's looking for people to come by. So we'll post all of these links in the show notes, but hopefully you can join him in Munich for the hackathon. Some cool projects that I found recently. John Evans, another one of our early adopters in the Dart community, wrote a great blog post about how he contributed to the Dart project. Dart is open source. You can find it at dart.googlecode.com. And he actually got his patch in and worked with the engineers to get it all reviewed and then talked about his experience. And so if you're interested about how he did that and how you might be able to contribute, go ahead and read his post. John also works on Dart code, and he ported a Z machine to Dart. You can find that on GitHub, which is very, very cool. A couple other cool projects. The GitHub user Mythz, M-Y-T-H-Z, wrote a Redis driver. Redis is a NoSQL key value store database that he's written the Dart drivers for so that he can plug Redis into his Dart applications via the Dart virtual machine. And the Google I/O sessions were announced. Most of them are now live, and we have 3 sessions this year at Google I/O. 2 sessions in the main tracks. One behind Dart with Lars Bach and Kasper Lund. And we also have putting the app back into web apps, which is talking about how Dart and web programming intersect. There's also a hands-on code lab for Dart as well, where you can get dirty with the Dart code and you'll learn how to write a client and server app in Dart. And so hope to see you at Google I/O, and if you can't be there, that's okay. Everything's being recorded, and a lot of stuff's being live streamed, so there's lots of cool ways to participate. And again, we'll post all of these links in the show notes as well later after the broadcast. So with that, we're going to welcome our special guests, some of our Dart virtual machine engineers, and we'll talk all about what's going on in VMland. So welcome, guys. Thanks for coming on to the show.
Thanks.
So let's go around the room really quickly so everyone gets an idea of, I'm really interested in who you are, but also what have you worked on previously? How did you become part of this VM team? We'll start here with Todd.
I'm Todd Turnage, and I've been on the team for, I don't know, is it a year now, something?
Somewhere like 9 months or so.
I used to do virtual machines back in the distant past, and I took a break from it for a while, but it's nice to be back working again with some people I've worked with before.
Mm-hmm.
Yeah.
Hi, yeah, my name is Shiva Anamale. I've been
here for close to, ever since the project started, so it's close to 2 years now, I think. And prior to this, I was also working on virtual machines for different languages in different companies also. Yeah, that's how I got into this.
Yeah. I'm Ivan Posla. Again, as Shiva, I was here from the start of the Dart project. Before that, I worked on V8 and then at other companies. I think I worked with everybody here in the room outside of Google already. So, yeah, mostly on VMs.
My name is Srđan Mitrovic. I worked with Edward here already before in other companies, and I've been working a little bit on V8, a little bit on other things in Google, and I have joined the Dart project from the beginning. Having a lot of fun.
Awesome. Thanks, guys. So building a virtual machine seems like black magic. This is always something that's below the covers, under the hood, if you will. So for everyone watching, can you help us just understand what a virtual machine is? Most people are familiar with compilers that generate machine code, and then you run that program. But what's different in a virtual machine world?
So I would say, first of all, we want to keep it black magic, so we won't answer the question.
Okay.
No, okay, so how did we start? Well, we had kind of an idea what the Dart language was supposed to do, right? So Shiva and I started in one area where we just said, okay, these are the VM objects that we need. This is the object hierarchy. The VM's internal data structures are also basically in the VM heap. They're garbage collected. So even though they're used from C++, we keep them there, right? And Shiva started then with handles.
Right. So essentially, we had the representation of all these Dart objects in the VM, but then we have to be careful in how we access them, be garbage collection aware and all. So we use this notion of handles so that the code in the VM itself is safe as far as people writing it and other aspects of it. So that's a pretty big aspect of the VM is infrastructure support for the garbage collector. And then of course there is the whole compilation, which Srđan can talk about.
Yeah, the key in that appears to black magic is we need a lot of discipline when we design the system, because the reliability and simplicity is of utmost importance. And the same is also for the compiler part, which I was working on, is to get a system that gradually improves the performance, which we are now on our way to do, and but still maintain the ultimate reliability, so that we cannot allow the users to have crashes while running our system. So we have to be disciplined and hardworking, and I think then black magic is not black magic, but white magic.
Good, yeah, magic for good. But I hear the terms engine and interpreter and compiler and virtual machine. So I'm familiar with, for instance, Ruby is an implementation that really is more of an interpreter, if I understand correctly. What's the difference between that and a virtual machine?
I wouldn't say there's a big difference, right? So all of these language virtual machines, right? They implement one particular language. They either use an interpreter, or in our case, we skip the interpreter step and go straight to generated code.
Okay.
Yeah, I think coming back to the black magic, both Shiva and Srđan touched on it, right? It's really I'm trying to keep the overview of the whole VM, trying to keep simple APIs, keeping the VM hackable, so that as you see changes need to be made, the APIs between the different subsystems are kept simple, and that way you can still, nothing is set in stone, essentially.
Yeah, especially this early in the project. It's still a technology preview. We're learning a lot of good lessons that we implement, other people implement, so that's good. We have to remain nimble.
And that basically allowed Todd to change big areas, right, of the isolate dispatching and so on.
Yeah, and we'll definitely come back to isolates. What about the lifecycle of Dart code then? So you mentioned that we skip the interpreter part, we go straight to machine code. At a high level, can you just walk me through, like, there's a compiler there. What happens when we take the Dart code?
Right. So essentially, we on the command line you specify a script that is the Dart code that you want to run. So essentially, the VM, when it starts up, it already does a boot kind of thing where it loads in all the core libraries which are out there. Actually, it's built into the VM. And then we load this script. We pass the script, tokenize it, everything. But we don't yet start compiling the methods at this point. We've just tokenized the stream, and then there is the main method that we invoke, and that's when the first compilation happens of that method. In the process, we are of course creating objects in the heap as we go along, like the script object and other things. And then once the main is compiled, we start executing that machine code, that is, which is compiled, and that in turn may call other methods which trigger compilation of these other methods, creation of heaps.
So it's like pulling on a string, right? Once Shiva said, once we tokenize the whole thing, we have all the VM internal data structures that describe all the classes that are part of this Dart program. All of the methods, we sort of know where the methods start, right? So when main calls some other method, right, we can pull on that. We have the pre-tuned, tokenized, right, contents of the script for that part of the method. So we can basically lazily, as you go, compile the little pieces, and yeah, that works actually pretty well.
Yeah, and the optimizing compiler kicks in later, right?
Yeah.
So essentially, we have that code that's tokenized, intermediate representation, and we have a two-stage compilation system, which first one collects all the necessary information about the runtime behavior of the language, of the program, and then from that one we decide to optimize, and we use all the latest and known and still unknown optimization technologies to get the best performance out of that.
Currently we optimize based on just a counter, right? But it might change in the future.
Yeah. Right. But this is a flexible thing. Right now we do simple so we can develop the prototype as soon as possible.
Yeah. And then the optimization steps currently are relatively simplistic, but they allow, again, as we try to grow and so on. Right?
Yeah.
So we get the type feedback from the running program. We know, okay, generally, or we've only see you call this dynamic method here, right? It always resolves to that other class, so we use that. We use that knowledge.
Now you mentioned performance, and I believe some of the people working on the Dart VM used to work on V8. Is that?
That's correct.
Okay.
Correct.
So what are some of the things we learned as we built V8 that prepped us for this next generation virtual machine, maybe in terms of performance? I know there's some things that we now know to do.
I don't see we have any issue. We need just time to implement all the features that we need. There are sometimes when you port a program from JavaScript to Dart and you don't think of Dart as a different language that may preempt you if you program it in a way like you do JavaScript. But if you program Dart like it's intended to be, you are going to see performance that is much better than a JavaScript system can provide.
So the lessons we took from V8, right, was Crankshaft, for example, showed that having a really basically two-stage compiler, that the second stage really kicked in and used all the type feedback and started doing advanced compiler optimizations, really pays off, right? So that is what Surgeon's doing, you applying some of those lessons, right? Go ahead.
The thing that we talked about of counting and this thing, it was proven that works very well in the crankshaft scenario too, as opposed to say some tracing or taking profiles, this counting scheme that they've adopted it too now, I guess.
Yeah.
Later.
Initially they used time-based profiling, and they switched to counters as well, right?
And I talked about object layout, like some things like that. Is that a performance lesson from V8 per se?
That is a performance lesson from V8. For example, what we did in V8 was initially we had just basically the object with the property values hanging off to the side. Mm-hmm. At some point, we had the object had some room for properties in the object itself, right? Mm-hmm. So that it didn't have to go through a double dereference to get that object. That it was something that really helped V8's performance. Mm-hmm. In V8 we have all these heuristics to figure out how big this area is. Dart as a language is much cleaner and safer that way. You can't add new properties, so you know exactly how much you need to allocate.
This is a really interesting point that I always find fascinating to watch the teams work with is the intersection between language design impacting VM design and VM design impacting language design. And it sounds like this is one of those areas where we knew from our prior experience that if you have a language where you can just add properties and methods at runtime, then you can't necessarily take advantage of some of the deeper optimizations.
That's correct.
That we then in the Dart language say, okay, well, if you can't add a property, then that means, well, we can be a little bit more smarter in our virtual machine. Yeah.
Or less smart, right? Keep it simpler.
Keep it simpler,
Keep it simpler, having fewer checks to execute at runtime.
Can you talk more about the dynamic between the language design and the VM design? Do you work closely with the guys building language? Do you think it's really just one big team? How does that work?
Todd, how loud do you have to shout until you reach Gilad?
The language specification fellow actually sits at the desk beside mine, so we have pretty much a direct channel to him.
That's awesome.
And he works a lot with the fellows over in Aarhus who have primary responsibility for language. But most of those people in previous lives were virtual machine engineers. So there's not really a wall in terms of the knowledge of virtual machine design. Generally, they try not to give us things that are too hard to implement or that we can't implement efficiently.
Well, I don't think they even thought about doing stuff that are too hard to implement.
Right. It just wouldn't have. They know it cold.
Yeah.
Even if we are in different time zones, I think the communication between Aarhus and us works pretty well. And we give them feedback when we find something that doesn't seem to be working well from the implementation standpoint. Because when you design, have a thought of something, you don't really know how well it works until you have put it down in the bits and bytes.
Yeah.
Right.
And that works well.
I think it helps that Casper is also basically working on Dart2.js, right? So they feel some of that same pain. Right.
So this always comes up, especially when we initially launched Dart, was, oh, that's great, you have a new language, but why not work on a bytecode VM and then let people kind of tack on top of that? Do you have any perspective on the design of Dart as it is today, where you have Dart code that runs just pretty much straight into the virtual machine? And what were some of the design decisions there? Like, why not a bytecode VM?
Yeah, go ahead. No, go ahead.
Well, to me, I look at it this way, right? When you have a bytecode VM, for Dart, similar to JavaScript, we always want it to be distributed as source code, right? No pre-compilation steps necessary for the developer. So you really want to be able to hit just reload. You change your scripts, reload, run, right? No compilation script to bytecodes necessary. Right. The option we could have had was that the VM itself then compiles the bytecodes, executes those bytecodes in an interpreter, and then basically does the optimizing compiler based on that, right? We've opted skipping that step instead of having a relatively simple, fast compiler to machine code. And I sort of look at the CPU as a really fast interpreter of these x86 bytecodes.
Yeah.
Right.
I don't see. And I used to work with bytecodes, and I don't see the clear benefits for us using bytecodes. It's an additional definition that we need to maintain, and main argument for bytecodes I heard it from other people who like to build other languages to run on our VM, and for that I think Dart is not a bad idea to use as intermediate languages by itself. So if you have a language, you can translate it to Dart and run it from that point.
Right. And if I can amplify, every additional layer you introduce is one more chance for your definitions to have a slight mismatch. And so you have a method call supposed to behave this way at the language level, but at the virtual machine level, maybe it acts slightly differently. It's just it's more areas where you can forget what's going on. And if we always know this is what the user typed in, then we can do what the user said to do at every point in time. There's no middleman.
Yeah.
Increased complexity. Increased complexity means both slower and less reliable.
Yeah, and it doesn't actually, the bytecodes don't actually skip the whole parsing phase, because we still have to do the verification of the bytecode that comes in, and so it's not like we're saving on the whole parsing thing and stuff. We still have to do it anyway, and having it in source form doesn't make it any worse. And like Surgeon said, interoperability is achieved easily because we already have so many translators to Dart language, and you can just run it straight, like as though it is an intermediate representation.
Good point. It's very web friendly this way.
Right.
You hit it best, where reload is the new compile.
Exactly.
So you need something that works like that.
Yeah.
Yeah, great, thanks. Switching gears a little bit, to me, one of the great novel features of the Dart virtual machine is isolates. I know you've been working a lot on isolates, Todd. Can you explain, what is an isolate? Is it a thread? Is it a process? What does it do?
Well, an isolate is a lot like a thread, but nobody else shares any of its state. So when you're writing an isolate, you know that there's no way that you have to have locking or race conditions or anything like that. There's just perfect safety. And all of your communication with other isolates is done with a message system. And so it's a nice abstraction for having parallel work, but without having a lot of the things that really require a lot of heavy thinking that you have in other languages. Here you have your isolate, and there's a very strong invariant about its protection. It's a lot more like a process or something.
Yeah.
Well, I've heard parallels drawn between our isolate system and Erlang actors, for instance. Do you think that's a fair?
That was definitely
part of the inspiration.
Yeah.
I mean, the big thing being that, as Todd mentioned, the heaps are isolated and there is no sharing going on, so it makes it as though you're just writing a single-threaded program. There's none of this whole synchronization complexities that people need to deal with.
Right.
And when you interact with other isolates, you just message them.
Yeah. It even applies inside the internal VM implementation. The fact that we know that this isolate's code can't really interact with this other one's code. It means that we can generate simpler code for them. We don't need to have a lot of locking that goes on there. I mean, we have a few data structures in the VM that have to do with how messages are passed back and forth, or about how threads are pulled from a thread pool that need to be synchronization aware, but most of the VM actually gets to be blissfully free of that. It's actually
essentially only the isolate implementation reads logs, right? And everything else is, you're the only guy.
Right.
So it's pleasing.
Yeah.
And I think part of the isolate design, I get the sense, is because Dart code has to compile the JavaScript, and JavaScript is itself single-threaded, and so I can see this interplay of requirements, but in the end, I think we end up with a really nice system. How are isolates implemented today? Is there a thread pool? Is it one process per isolate in VM? Or?
Yeah. About a month or so ago, we switched from, we used to be thread per isolate, which obviously doesn't scale well. When you're building a virtual machine, often you'll say, I want to get something working now, and then I'm going to make it better and better. And so we have this sort of iterative, incremental improvement. And one of the things we improved recently was we added a thread pool. So if a certain isolate is gone to sleep, it's waiting for a message, and it'll be woken up when it gets the message sent to it. Its thread goes into the pool, and then the next isolate comes along and needs to run, it can share it. So it allows us to scale more isolates on top of fewer threads.
Yeah.
There's still more to be done, right?
Yeah, absolutely. We're not. It's an area that we just scratched the surface on.
Right.
So, for example, currently we have the initial heaps for per isolate are much bigger than we would want to, right? So we want to basically grow them as needed, right? We have still a lot of the core library that is loaded, right?
Yeah,
is on a per isolate. It's currently loaded per isolate.
There's a lot of read-only data that comes in as part of the boot process that is not modified and can be shared across the isolates. So that's something we're looking at to see how much of it. Again, this goes to Todd's question of reducing the footprint of an isolate, like how the thread pool did it.
Yeah, just basically starting to squeeze on it.
And so do you think that when further iterations of the isolate subsystem appear, is the expectation that developers can start up a large amount of these isolates? Are they intended to be lightweight constructs?
Yeah.
Great, for sure.
Yeah. And again, as Todd said, currently an isolate becomes runnable, it gets a thread, right? And we might basically want to limit how many threads we want to create, right? Currently we just create if you have 100 isolates, right, that want to run all in parallel, currently we create 100 threads. Maybe we'll try to limit that at some point, right? So that they start sharing threads and so on. But currently this is not a complexity that we're trying to address because there are bigger fish to fry.
Sure.
We do reclaim idle threads right now. So if you reach some peak and you go down, we'll reclaim them if they're fallow for a while.
Yeah.
Well, this is probably an area that we'd love feedback from our external users. How are they using isolates? What kind of systems are they building? What kind of limits did they run into, and what are the use cases that prompts these limits? So I guess this is a question really for everyone watching. Do try out the isolates on the virtual machine. Try it with your systems, your libraries, and let us know how it works for you, what kind of additional control you might need. And I'll take this opportunity to remind everyone this is Dartisans episode 5, where we're meeting with the Dart VM team today. And you can follow along at html5rocks.com/live, and we have a moderator and a chat there, and so you can participate there as well. So I have a couple more questions, and I think we'll dive into the moderator questions. So what are the plans for debugging? I saw some debugging already from the editor that goes into Dartium, the web browser. What's the team working on right now in terms of debugging?
So in terms of debugging, Matthias isn't here, so I'll try to answer for him. In terms of debugging, the first effort was to be able to debug Dartium, right? So you have an app in your web browser, hook it up to the Chrome Developer Console, set breakpoints, inspect the stack, variables on the stack, and so on. That is mostly working. I'm sure there are still some gray areas and stuff that is not implemented properly, but the feedback I got from some of the developers was very positive, right? And then we switched gears a bit. Now it's being able to debug standalone programs, be it scripts, be it server programs. Generally, we talk about Dartium and how Dart is inside Chrome, but with Dart.io, you can build pretty beefy servers. We use some of it for our internal Dart infrastructure for testing and so on. So you can build pretty beefy programs. So far, Mads and his team have been doing print debugging, right? So they want to have something that is more like a real developer experience for those programs. So that's what we've been doing. And there is a wire protocol being defined. It's JSON to some debugger process, right? You have the debuggee, and I know Matthias has been working on a basically small Dart program that can be used as a debugger itself, right? Like a command line debugger, or you hook it up with the editor.
Right. Yeah, that's his kind of a test program for testing the wire protocol. Yeah.
And I think if it becomes useful, that test program can actually mature into something that you can use, like GDB, let's say. Right?
Yeah.
From a command line.
Debugger.
Yeah.
But I think this is a great clarification for everyone watching, is that Dart, the virtual machine, is not just targeted to web browsers, right? As you were mentioning, we have a suite of I/O libraries like files and directories, raw sockets, web servers that all run from the command line essentially as a server. And the hackathon attendees, for instance, many people were doing client and server-based apps.
Okay.
And many people were asking about the debugging, and so it's cool to see that that's on the radar. But I love that about Dart. You can have the same code on the client and the server running, and some nice code sharing, and it's cool. Same constructs in both places. Another big feature that always comes up in conversations I get in questions is reflection. How will reflection work in Dart? And we hear rumblings of this system called mirrors. And I think, Todd, are you working on mirrors?
Yeah.
Can you talk a little bit about...
I'm getting to do a lot of fun work.
all the new stuff. So what are mirrors? Why not just simple reflection?
Well, one of the people on our team, Gilad Braca, he wrote interesting paper about mirrors. It's just an approach to reflection that tries to avoid certain downfalls in other systems. Each object has a associated object called a mirror, and the mirror could refer to a local object or a remote object, and you interact with this mirror to have it do all of the reflective operations. And he argues a lot for it in the paper in terms of he stratifies which things you can do at which level, and it tends to make a cleaner conceptual break in a system. And it also tends to be more of the thing you could take one mirror implementation and substitute in a different one. Like, so this one might be your local mirrors, this one might be your remote mirrors, this one might be a different kind of mirrors that instead of going on a live program reflects on a language database, on a core dump or something like that. And so it's a lot like dependency injection. If you design it right, you can inject a new library implementation. So in terms of implementation, it's still early days for that. We're just beginning to implement his proposal and flesh out the details of that.
Okay.
Yeah. Also, some of the ideas he has is that you can have that mirrors can have certain capabilities. Maybe you can only inspect, not change a program and stuff like that, right? He wants to use he wants to be able to use mirrors to build out completely new isolates, right? So you basically use, okay, give me a new isolate mirror, right? I want to load this library into it, and this other library into it, and then I add this code, right? And then invoke another method, right? Or maybe even pre-populate it with some state, and then call this method on it, right? So it's really like
it's like dynamic kind of code loading kind of thing.
Legos for your program, and then you say, okay, now it's done, run, right? And mirrors are then strong enough to kind of do the reflection yourself, or basically do more than just reflection on yourself, right? Build up new objects and so on. Right?
Are you aware of any other systems that use this concept of mirrors, or is Dart going to be one of the first or the first that is implementing this for real world kind of applications?
You worked on Strongtalk, right?
Yeah, I worked a little bit. I was mostly involved in other parts.
Did he do it with this other language?
Yes. I think Newspeak has it, so it's been around for a while. These ideas, they've not been used too much, right? But on the other hand, for example, if you use V8 and use the debugger in V8, all of the debugging API behind the scenes is implemented with these mirrors, right? So even you can't really tell, but that's what it uses underneath, right?
Well, this is a hot feature request, so it's cool to hear that we have a really solid plan. We've seen this implemented in other languages, and it's coming for Dart. I think will enable a lot of great lower-level libraries that people will build on top of. Things like JSON parsing could really love the mirrors, as you could reconstruct an object based on some text stream. So, yeah, that's great. Before we dive into questions, I have another question about language design impacting VM design. One of the more novel features of Dart is its optional static type annotations. And I'm just curious how that might have impacted at all, if at all, the VM design. Did you have to go to a new place in VM design because of these optional static types, or is the way they design, they're pretty decoupled and it really didn't impact? What was the intersection there?
So optional typing is known from JavaScript and from Smalltalk and so on. Now, in addition to that, we need to do these optional static runtime checking. So those checks need to be eliminated, need to be efficient, and so on and so on. We have a lot of novel ideas how to do this correctly and efficiently. We're not yet there, so the running check mode is still a little bit too slow for our taste. We are working on making the check mode as fast as we can, and putting optimization to get this done. So making these optional runtime checks very quick is a challenge. We have found that a lot of the idea of optional typing and it's kind of novel to many people who are accustomed to using static typing, and I think there's a lot of people have to get used to that. How they can use that efficiently in their systems is a challenge, but I think it's worth it.
Yeah, I think it really, you can tell some of the team members skip the V8 step, right? In V8 you have in JavaScript you have no types, you have no static types, so you always have to figure it out at runtime. For some that came from statically typed languages, right? It was hard to let go of, but it's right here, it has this type.
Yeah.
Well, this is only, it is not guaranteed to be correct, right? So it is otherwise, so unless you're in check mode, you can't really rely on that. So you really have to, even though from the VM's perspective, even though a type is specified, we read it as a var. We don't know anything about it until we get the type feedback.
Right. And that's where that check mode, as you were talking about, comes into play. For those who don't know, Dart can run in really two different modes. One mode we call production mode, where all these optional static type annotations are effectively ignored, where you're saying you just see var. But then you flip a flag and you get checked mode, where the VM and the other runtimes begin to respect these optional static type annotations can do some dynamic type assertions.
Yeah, it's developer mode, more like it, right? So you're expecting this type T here, right? And you make sure that the variable being assigned has that, or the value being assigned to this variable has the appropriate type. Right?
It's important to know also that when you add types to Dart, it doesn't improve your performance.
Yeah.
So we are not using the type information to generate better code. And we feel we don't need. I think with all the object-oriented technology that we have to our disposition, we don't need that to generate code of high performance.
Great.
It's more for improving programmer productivity in terms of making the code more legible and how they're structuring it and things like that. I mean, everybody knows JavaScript is probably hard to read and understand over time. And that's one of the prime goals was that.
Yeah. And then you can have the static type warnings on top of it, right? During the runtime. We don't look at it, but ahead of time, you already got static type warnings from the editor.
Right.
You're assigning something that doesn't match here. Is this really what you want? And occasionally, you know better, right? But
and for those that do use the editor, you get the static type warnings. And if you don't use the editor, there's a standalone program that we're continuing to improve, which can run through your code and give you these static warnings. So you can integrate into your toolchain as you see fit. So it's really, really nice.
Yeah.
One other feature I remembered of the Dart virtual machine is snapshots. Has anyone been working on snapshots lately?
Yeah, I mean, we did an initial round of snapshotting the whole code library, and in the case of Dartium, the whole DOM and HTML libraries, which are kind of now inbuilt into the VM. So anytime an isolate is started, it doesn't reread all these code libraries. It just starts off from that snapshot. So what the advantage of that is, you don't have to tokenize the whole thing again. So you get that all a priori, and it kind of speeds up the starting process. Apart from that, we also have something called application snapshots, which Dartium has been using it, in that when you first load an application, it creates a snapshot of that application, stores it off in the browser cache, and then subsequent reloads of the page pulls that from the browser cache and runs it, which again, the advantage is it skips over all the tokenizing and the whole parsing parts of it.
Does the snapshot system, this might be a Dartium question, but how does it know to expire that snapshot? Does it look at some of the headers coming in from the source file?
Yeah, it's the same standard browser cache expiry policy that they have in the regular browsers. It's the same thing is applied to this too, and it expires.
They just stick the binary blob into the cache instead of the resource they loaded, right? Or next to the resource they loaded. Maybe we need to take a step back. What is inside a snapshot, right? So, as we said on your earlier question, how does it even get going? What do we need to do to start up a VM, right? It's really, well, we parse the program, right? We build up its internal data structures. So that we don't have to re-parse the individual characters, right? We have this, what we call a token stream. So all of that structure lives in the snapshot. So when you reload the snapshot, basically this whole structure of these classes are in this library, these methods and fields are associated with these classes. All of that is basically read in from a serialized object stream. So right, these objects are recreated again immediately without any real parsing going on. So that's basically where the snapshot starts. That's why Shiva can say, well, you have a snapshot, you just reload it, boom, here's your VM, right?
So the way to look at it is it's a snapshot or an image of the heap that was there after we did that initial parsing and built up all the initial data structures and stuff. So that heap has been dumped into this, serialized into this buffer, and then we deserialize it the next time we load it, so that the heap just comes up without having done any of the initial parsing and all that.
Yeah, I don't know, some of the viewers might have seen when they looked in the V8 implementation details, right, there is a snapshot there as well, because V8 has some areas of the JavaScript libraries are written in JavaScript itself for V8, right? So what V8 does, it basically snapshots that part of the core libraries, right? The problem for JavaScript versus Dart is that to build up your program structure beyond what is really known to the VM itself, right, is it needs to execute code, right? And to properly be able to snapshot things, it's really hard to figure out once you start executing code. With the Dart language, you have the structure is in the class, not as executing programs. It's in the source code. So that's why we can snapshot bigger things, even applications.
I think some of the initial research I think the Seattle team did was 10 times better startup performance due to snapshots, and so I'm really looking forward to that.
Yeah.
So let's go ahead and take some of our viewer questions from the moderator. If you're just joining us, html5rocks.com/live has a link to this moderator. You can vote up and down questions or ask your own. We'll start right at the top. Our buddy Ladislav, who is prolific on the general discussion mailing list. So thanks for all your help there.
We should say hi to Ladislav.
Hey.
Yeah,
I see a lot of his emails.
Oh, yeah, XML.
Thanks for helping. He asks, if I understand correctly, isolates are meant to be very lightweight in Dart, yet the VM trashes my OS badly if I create like 100 of them.
Yeah, he has a bug open for this, I think.
Okay, what are the intricacies in this, and how do you plan to tackle them? So I know we talked about it a little bit, but if there's a bug, we thought about anything more?
Well, I mean, I need to re-review the bug now that we have the thread pools. I think the bug was filed before that.
Mm-hmm.
And then there's just, we consume a certain amount of resources per isolate.
Correct.
And we need to just start turning the screws on that. And then there's even some objects that we could share across all isolates.
Mm-hmm.
Yvonne did some work recently with something called class indexes that are where an object doesn't need to refer to its class from its own heap. It can refer to just the general notion of I am a string. And then what a string is in isolate 1 might be a little different than this one, but we can actually share the data.
Mm-hmm.
And so we could start to actually share a lot more between isolates. I don't know if that'll help with, it'll help with scaling.
Oh, it will help definitely on a per isolate overhead. Currently,
per
it's
isolate
much higher
overhead
than
is sort of what's trashing
Yes.
your OS probably there.
If it's not the threads anymore, then it's the per isolate overhead is much higher than we want it to. We have a grand plan to get there, right? And it's essentially the three of us that need to get some of these ideas that we hashed out implemented.
Mm-hmm.
And also our heap policy right now is not that great, so we tend to just keep growing the heap, and so the isolate takes more, the footprint starts to increase, and I think Ivan has a plan on trying to do a more progressive growth of the heap, so we should reduce that footprint also.
Mm-hmm. Cool. Well, it's great to hear so much interest and attention from the outside world and then from the VM engineers as well. So Adam, who's another one of our early adopters up in San Francisco, actually asks, I just lost it. Can you explain what object tagging means in the VM world? Looks like he's someone that likes to dive into the source code a little bit. Is there a way to answer that?
It's unclear what. Well, I think I know what he asks.
They asking about small integers and things?
I think that's what it is, right?
Actually, can we, if he's alive, can he ask us what exactly he meant by object tagging?
Okay.
Because I'm a little confused of what he meant by object tagging.
We'll follow up. I know he's on another event today, so Adam, we'll follow up with you offline. Ask again on the mailing list.
But maybe he
talk
can
about
speculate
small
on
integer
what.
tagging.
Okay. If I heard this question without any, I thought maybe we can get a little bit more info what he wanted to know.
Mm-hmm.
In the VM, we like a lot of the language virtual machines that have that don't have static types for integers and other basic types, right? Integers are really, really frequently used, right? So what we do is we have pointers that we just add the low bit as 1, right? That means those are tagged, these are real pointers, right? And then integers themselves, all integers have the low bit 0. They're basically shifted by, one bit to the left. So we have, instead of 32-bit integers on a 32-bit machine, we have 31-bit integers that we can very efficiently represent in the VM. And So the low bit really tells us when we look at what is an object reference, right? The low bit tells us, okay, this is what we call a small integer, a 31-bit integer on an x86, right, or an ARM, versus a real object pointer that we have to, where we can get at its class and its fields a different way, right? If we try to call integer methods on one of these SMIs or small integers, we can't load the class out of the object because it's not there. We have to find the class somewhere else. Right? That's where the class index and so on helps us as well, because we can just load it.
But it means that we can compile pretty efficient code for integers.
Yeah. And it works so smoothly. For example, sometimes we have two operations between those two 31-bit integers that produces an integer that is larger than 31-bit. It creates an object that gets tagged, and we present that new integer in the appropriate way.
Yeah. So it's to the user, it's completely
Right.
transparent.
Yeah.
Right. For us, it makes it easy to, especially for the optimizing compiler, right? You just basically, for a lot of operations, you can just do normal integer operations. You check whether the low bits have been set, right? And then you're back off to the races.
The performance-wise is an incredible help, and it's very simple to implement. The next step, for example, for doubles, we cannot do that, and all the double operations need to go via objects in the unoptimized version. We're working very hard on making doubles, real doubles at machine level, and to bring the performance way up.
Yeah. And then on a 64-bit VM, a lot of people, I think, are starting to use that as well, right? On a 64-bit VM, well, it's 63 bits of small integers. I think
Just
that
a
is
lot of small int.
Yeah, that is a pretty large value for a small integer.
Yeah.
And then we have a couple behind the scenes, right? We have this whole integer hierarchy. It's from a small integer, you flow over to a medium integer, which is really a 64-bit value. It's heap allocated, right? But then we just use the regular machine instructions to operate on that, and then you flow over to a big int, which is arbitrarily sized.
And we should probably talk about the language semantics, or that integers are arbitrarily
sized.
or bound. Yeah. And great. Well, okay. We've got about 10 minutes left. Song-Hoon Kim, who leads the Korea Dartlang user group, asks, are we sharing any benchmarks between the Dart VM and V8? And what I think he's really asking is, how are we kind of measuring ourselves?
Yeah, we have benchmarks written in JavaScript and in Dart, and we run them. The JavaScript benchmarks we run on the best JavaScript engine available now, which is V8, and compare it with the Dart results. We track this on a daily basis, and we are seeing improvement, and we will see more and more improvements until we are considerably faster than V8.
Okay.
Currently, I don't think we're there yet.
Yeah, still very early, but it's great to hear that we're tracking this stuff.
Absolutely.
Yeah.
Another question, but I believe probably came in from the comments or the chat stream, was what types of things are being put into the Dart VM to allow developers to control/be notified about GC events? This is a large problem in high-performance JavaScript applications where apps can't control when a GC flush occurs. Any thoughts about, I think this is really asking about two things. One, he's asking, can I be notified when GC occurs? And two, can I control when a GC might occur? As VM engineers, I'm sure you've seen systems built one way or the other. What are your thoughts there?
In terms of notification, the Dart API, if I remember right, the Dartium did request it, and there is a notification that we call back from the Dart API thing. It's
At the embedder level, you can certainly...
As an embedder, you can actually register yourself.
You can have prologue callbacks and epilogue callbacks and weak reference sets and the whole thing.
Right. But in terms of controlling it, I have some strong views on that. Maybe others don't share it, but I've generally felt that trying to control when a GC happens is not quite a good approach, because the garbage collector does have heuristics built into it to control these things. And in general, it has been, at least my experience with these things, have been that a nicely implemented garbage collector and a VM does a pretty good job of knowing when garbage collection should happen and does it.
So when you look at other languages that allow exposure of the GC event and trigger a GC here, right? Good VMs implementing these languages generally ignore these calls, right? Because it's been often, in our experience, right, it's been often at the wrong time.
And also, I mean, we've got a different environment because we have per isolate heaps.
Right.
So in other systems, you might have a stop the world GC where it actually affects all threads.
Yes.
Right.
Here, there's no need for any other isolate to stop just because one isolate needs to GC.
Right.
Also, you should also expect that that heap will be sort of proportional to the size of the work that isolate's doing. And if it's that isolate's heap might be a lot easier to collect than the whole thing.
Sure.
So in terms of global hiccups, you should expect fewer. And we hope they'd be smaller. But I'm not a GC guy.
No, and currently there's a lot of work that I and Carl need to implement.
Yeah.
Maybe with help from Slava or somebody else, right? In the GC, as Shiva mentioned already, the growth policy is completely not implemented, right? So we just keep growing old space until you reach its max limit, even though we know that maybe there's not enough live, right, to warrant the growth of into the next size. Right? That would be more efficient to collect now, right? And stuff like that.
Well, I'm wondering also if the tooling systems can also help developers with large memory, high-performance applications as well. I know that developer tools in Chrome give you some visibility into what's going on. So, the feeling here is not being able to manually trigger is probably the right thing, but I think we could do things at the tooling level to help people get visibility.
Right. I think Carl has a prototype where he kind of gives you a heap dump. What is live now, right? And where is it being held from? And you should be able to graphically inspect. Here's this object. Why is it live? Who points to it, and so on.
Yeah.
How far he's along with that? It's I don't know.
Well, I got a couple more questions. Ladislav asks again, as far as I know, the coming debugger communicates with the VM via a JSON-based protocol, which I think we covered earlier. My wild guess is that this must bring some overhead and that some binary format like protobufs might be more efficient. Is that the case, or am I wrong? Is what I ask.
It's probably JSON or protobufs or some binary format would be more compact, right? Might be easier to parse on the other end, right? I don't think it's huge, right? And you're dealing with a human, right?
Yeah.
So the latency.
Nobody writes. We don't generally have debugger benchmarks that we pay attention to. I mean, I guess probably people who do GDB do, but like generally, if you hit next and then in a reasonable amount of time, you see the next statement come up.
Usually it's not the wire protocol that dominates in Next, and there's a lot more things going on behind the scenes for an implementation of Next. And the trade-off here is, of course, JSON is a pretty popular format that a lot of other tools might already be aware of using it. So the trade-off is pretty good in that aspect, right? So we get a protocol that a lot of other people might already understand, as opposed to a proprietary binary format.
Right. Human readable is always nice for debugging in these areas. Right?
I think I agree.
I mean, debugging the debugger protocol, right?
Right.
So that gets us probably there more quickly than if we had to count bits on the wire when we're figuring out why doesn't this work.
And just like most things that we're working on now, this is all early days, and so who knows what the future will bring. But I agree, like less moving parts, less unique capabilities, more human readable at this stage, probably better.
Right.
Yeah. Okay, great. Well, last question, something a little bit different. What types of things would game developers need to be aware of at the VM level to write high-performance code? And to elaborate more, we have the question asker here on the other side of the camera, Colt, who is a very experienced game developer, and I know he's been working a lot building web-based games. So is there something that you were particularly, like a angle on that question?
Just the larger deep dive. When game developers are writing HTML5 code, they have to have the mental model of how JavaScript is working, and then the secondary model of what that actually turns into on the other side of the fence. I didn't know if there was anything you guys have done already with performance or profiling that you may want to think about or be aware of, or at least notify the community of, that are things that they should start thinking about when trying to write games that run at 60 hertz with full graphics and sound running and networking and everything.
Okay. So I think I would start off with don't mix ints and doubles, right? Excuse me. In JavaScript, you don't necessarily have that problem because it's just kind of a big mishmash in the number hierarchy. For us, it's really helpful if you say, I'm going to use this as a double. Define your constants as 1.0 instead of 1, stuff like that. That helps dramatically. Some of the type feedback, I think, will make this easier to deal with in the optimizing compiler.
I know games do a lot of matrix math.
Right.
Yeah, tons. Lots of linear algebra and array traversal.
I think it's important not to deduct certain performance characteristics from where we are now, because where we are going to be quite different. So if you figure out, oh, this, if I do it that way, it's going to be much faster than the other way, doesn't mean it's going to stay that way. So we are trying to improve, we are focused on improve the normal code, which means write clean code, simple code. Don't go, oh, if I code this and this and that, and then I'm going to get faster because I made it right now. That's maybe not going to be in the future. Simple code, clean code should work very good.
Yeah, and if it doesn't, that's a bug. Yeah. The other thing is we already have the whole native arrays for floats, and then they're typed, right? So you can really say I want a float 32 or a float 64 arrays. You can have them external if you want to, so that they're shared with the graphics card and so on from a web developer's perspective. Unfortunately, I think they're not exactly hooked into Dartium yet, right? So I think that is the next step, right? So in the VM they're supported, but if you ask for a type array from Dartium, you get a different copy.
I hope in the future we'll be able soon to get with a more precise set of recommendations for the performance, but now it's way too early for that.
I think we have Box2D wired into some of our performance metrics, so that's something used by a lot of web developers, and that's good. I think as long as it's on that radar, that's great. Well, I think that's all the time we have today, so I want to thank everyone for watching and certainly all your questions. And then, of course, our engineers from the Dart VM team, thank you very much for spending your time with us today. This is all going to be recorded and posted to our YouTube channel, so you can catch up there. And please do follow Google Chrome developers and Dart structured web apps in Google+ for more hangouts like this, and where we post news and announcements and interact with the community every day. So thanks everyone for their time, and we'll see you next time on Dartisans.
Thank you.
Thanks.